Have humans found extraterrestrial life? The answer is, almost. In September 2024, the James Webb Space Telescope detected dimethyl sulfide in the atmosphere of a planet 120 light-years away from Earth. On Earth, this gas can only be produced by living organisms, and its concentration was absurdly high, 20 times higher than what Earth's oceans release. Even stranger, this super-Earth called K218b has a surface temperature right between 0 and 100 degrees Celsius. Scientists also detected water vapor, methane, and carbon dioxide in its atmosphere at the same time. What does it mean when these three substances appear together? It means there may be oceans there, and life. But that's not what excited astronomers the most. In early 2025, while analyzing this planet's spectral data, scientists discovered a chilling detail. Its atmospheric composition had fluctuated by 0.3% over the past 6 months, and this fluctuation showed a kind of seasonal pattern, as if something there were carrying out metabolism. So the question is, if there really is life there, what would it look like? To answer that, we first have to understand what life actually needs. Scientists have summarized 3 essential conditions for life: liquid water, an energy source, and organic molecules. Sounds simple, right? But did you know that just within our own solar system, there are at least 8 places that meet these conditions? The first, of course, is Mars. In 2018, the European Space Agency's Mars Express probe discovered a massive reservoir of liquid water, 1.5 kilometers beneath the south pole of Mars, covering an area of 20 square kilometers. This is not ordinary water. It's super salty brine that won't freeze even at minus 70 degrees Celsius. Even more astonishing, the Curiosity rover detected organic molecules in rocks inside Gale crater, and their concentrations change with the Martian seasons. What does that mean? It means there may be microorganisms underground on Mars, constantly producing and breaking down organic matter. The second place is even more insane. Europa, Jupiter's moon. This frozen moon is covered by an ice shell up to 15 kilometers thick. But beneath that ice lies a global ocean more than 100 kilometers deep, with 2 to 3 times as much water as all of Earth's oceans combined. In 2023, scientists observed with the Hubble Space Telescope that cracks in Europa's ice periodically shoot water plumes up to 200 kilometers high. Even more terrifying, spectral analysis of these plumes revealed sodium chloride, common table salt. That means Europa's ocean has a chemical composition extremely similar to Earth's oceans. But the most exciting discovery is this: Europa's seafloor may contain hydrothermal vents, just like the black smokers in Earth's deep oceans. These vents out mineral-rich hot water that provides energy for life. And on Earth, massive communities of bizarre creatures live around black smokers, without needing any sunlight at all. The third place completely overturns everything we thought we knew about life. Titan, Saturn's moon. This mysterious world is basically another Earth. It has a thick atmosphere with pressure 1.5 times higher than Earth's. It rains, there are rivers, lakes, and a complete hydrological cycle. The only problem is, what falls from the sky isn't water, it's liquid methane. And the temperature is minus 179 degrees Celsius. But here's the crazy part. In 2024, computer simulations showed that under such extreme cold, an entirely new form of life might exist. Their cell membranes wouldn't be made of phospholipids, but of acrylonitrile molecules. Even stranger, the Cassini probe detected much less hydrogen in Titan's atmosphere than theory predicted. Where did the missing hydrogen go? Scientists suspect it may have been eaten by some unknown organism. The fourth place is Enceladus, Saturn's moon. At its south pole are more than 100 ice volcanoes, spraying 200 kilograms of water vapor into space every second. In 2017, when Cassini flew through these geysers, it detected hydrogen, carbon dioxide, methane, and complex organic molecules. Scientists calculated that hydrothermal vents on Enceladus's seafloor could reach temperatures of 90 degrees Celsius, with a pH between 8.5 and 10.5. This environment is almost identical to the one that gave birth to the first life on Earth. In other words, Enceladus may be replaying the story that happened on Earth 3.8 billion years ago. So here's the question. If there are so many places in our solar system that could host life, why haven't we found any yet? The answer is simple. Our probes can't reach deep enough to drill through Europa's 25-kilometer thick ice shell. With current technology would take at least 30 years. And even if we did drill through, we wouldn't know how to search for life in the high-pressure, pitch-black deep ocean. But scientists haven't given up. In 2030, NASA will launch the Europa Clipper mission. It will fly low over Europa's surface 44 times, using radar to peer through the ice and analyze the composition of the erupting plumes. If we're lucky, we might directly capture extraterrestrial microbes in those fountains. And beyond our solar system, humans have already discovered more than 5,500 exoplanets, at least 50 of which lie in the habitable zone. Their temperatures, sizes, and distances from their stars are astonishingly similar to Earth. The most sensational discovery of 2024 was a super-Earth called K218b. It has 8.6 times Earth's mass, orbits a red dwarf star, and the James Webb Telescope detected methane, carbon dioxide, water vapor, and most importantly, dimethyl sulfide, in its atmosphere. Do you know how important dimethyl sulfide is? On Earth, 90% of this gas is produced by marine plankton. If large amounts of dimethyl sulfide really exist in K218b's atmosphere, there is only one explanation. There is life there, and a lot of it. But the most shocking part isn't even that. In March 2025, scientists analyzing transit spectra discovered that K218b may be an ice-covered ocean world. Its surface is sealed beneath a thick ice shell, but underneath lies a liquid ocean hundreds of kilometers deep. And below that, a hot, high-pressure rocky mantle. This structure is almost identical to Europa's. The difference is, K218b's ocean is 10 times deeper than Europa's. If life really exists there, it would be the largest extraterrestrial biosphere humans have ever discovered. So what would these alien lifeforms look like? If they're microbes beneath Mars, they might resemble Earth's extremophiles, tiny, slow metabolizing, capable of surviving for hundreds of years in sub-zero brine. If they live in Europa's ocean, they might evolve enormous eyes to adapt to the darkness. Or bioluminescent organs like deep-sea fish. They might feed on sulfides from hydrothermal vents, and grow as large as Earth's giant tube worms. If they live in Titan's lakes, that would be pure science fiction. Their bodies would be made of liquid methane. What flows in them wouldn't be blood, but liquid nitrogen. They might float like jellyfish on methane lakes, absorbing organic molecules from the atmosphere for energy. And if K218b truly hosts ocean life, their size might be beyond imagination. Because K218b's gravity is 2.6 times Earth's, and its oceans are 10 times deeper. Under such crushing pressure, organisms might evolve ultra-hard shells, and reach sizes as massive as whales. But the most unsettling possibility is this. If life truly exists on these worlds, their evolutionary history may be far longer than Earth's. Europa's ocean has existed for at least 4 billion years, Titan's methane lakes for several billion years, and the red dwarf that K218b orbits can live for trillions of years. What does that mean? It means life there may have been evolving for billions of years. Their civilizations could be far more advanced than ours. Perhaps right now, intelligent beings beneath Europa's ice are sitting in underwater cities, using methods we cannot comprehend, discussing a distant planet above the ice, called Earth. Humanity's search for extraterrestrial life has never stopped. In 2028, the Dragonfly drone will land on Titan, flying between methane lakes in search of signs of life. In the 2030s, humans will send drilling robots to Europa, attempting to pierce the ice and directly explore the ocean. And far across the cosmos, the James Webb Space Telescope is operating 24 hours a day, monitoring the atmospheres of habitable planets, searching for the chemical fingerprints of life. Perhaps in the near future, humanity will finally confirm that we are not alone.